I thank you, sir. So I'd like to introduce you to the city of Yale, Oklahoma, which consists of 1,227 people, 6 churches, 4 restaurants, 2 gas stations, and 1 grocery store. And the people of Yale, Oklahoma, and the surrounding communities realized a couple of years ago that they had a problem. And this was their problem, the Cottonwood Creek Bridge, which was built in 1961. And at first, that doesn't sound so bad, till you realize, like me, this bridge was in its early 50s, being asked to perform at a physical level like when it was young. And when I think about the way my joints felt this morning, you realize this was a catastrophe waiting to happen. So this bridge was badly deteriorated, in need of repair. Also, it was way too small for modern traffic patterns. So let's go ahead and replace the bridge. Except there are 2 complicating factors. Number 1, the bridge is the only way in and out of Yale, Oklahoma. So if you want to go across the street to your farm, you would have a 29-mile detour to get to work and 29 miles coming home. It'd be a big inconvenience for the people who live in Yale, Oklahoma. And it takes 6 months to build a new bridge. That's how long the road would be closed for. Issue number 2 is the area surrounding the bridge is the Cottonwood Creek, which is part of the Keystone Wildlife Management Area. There are fish and birds and turtles, and a major construction project could damage the wildlife. So what are we going to do? Well, it turns out that this is a big problem across the United States. The U.S. Department of Transportation says that 40% of the bridges in the U.S. are 40 years old or older. They're all going to be shortly in need of replacement. So they're exploring technologies to replace these bridges more quickly. And these are called ABC technologies, accelerated bridge construction. And the idea is, can we shorten these road closures so we don't snarl traffic? Can we have less environmental impact? Can we improve worker safety? So one of these ABC technologies is called bridge sliding. And it sounds very easy in principle, but it's actually very tricky. So you have the old bridge, and you're going to build a new bridge right next to it. You're going to build the supports for the new bridge right underneath the old bridge while you leave it open. Then when you're all ready to go, you knock down the old bridge and you slide the new bridge into place. And that should shorten the road closure and the environmental impact. So this is where performance plastics comes in. So I picked up on that, Kevin. Gus Hammond, the engineer on the bridge, called me and Jeff Rogers, a rep in Texas, and he says, I really need some help picking a plastic that'll allow me to slide an entire highway bridge into place. And we said, okay, tell us about what you need, Gus. He said, well, the first thing is it has to withstand a load of 1,200 kips per span. We said, that's terrific. What's a kip? And he told us a kip is a unit of measure that they use in the construction industry. When we did all the calculations, it was just over 1,000 PSI. He said, okay, number 2, it's got to be really slippery. I said, well, can you apply grease to the plastic? Well, yes and no. He said, there's environmental impact. We're not allowed to use any petroleum grease or any oil because it can hurt the turtles and the fish in the creek. Well, what are you allowed to use? Well, the only thing we're allowed to use is Dawn dishwashing liquid. We bought 25 gallons of it and we're ready to go. Dawn dishwashing liquid, okay. I said, what else? He said, well, it's got to be available in big pieces, 2.5 inches thick, 8 inches wide, 10 feet long. We're going to need 30 of them. So there goes Vespel. I couldn't recommend that for it. And here's the final thing. He said, this has got to be tough. It's got to be ductile. Even in cold weather, it can't crack. Well, why can't it crack? And so what I came to find out from Gus, for those of you who haven't worked in construction contracts are a little like a game show. They said, well, you have 21 days to complete the project. If you complete it quicker, you win. and we're going to give you a bonus of $20,000 a day. However, if you don't hit your 21-day target, you lose, and we're going to bill you $20,000 a day. So he said, Keith, your plastic cannot crack. So he said, well, in terms of the loads and the coefficient of friction and the ductility, we decided to select ultra-high molecular weight polyethylene for the project. So here's a shot of the old bridge with the new bridge being built right next to it. And at this point, the old bridge is still open. Over here, you can see the supports for the new bridge being built right underneath the old bridge. And if you look closely, you can see the trucks are still going back and forth across the bridge during the construction project. So now they have the supports all ready to go. And here's a schematic of the UHMW parts. And you can see they're 10 feet long. And we had to cut this zigzag groove in each wear pad. And that's so the guy with his bottle of Dawn dishwashing liquid could fill the groove with Dawn so they could slide this bridge into place. It's also important to note we had to chamfer the edges. There's no way we wanted this to get stuck as they started to slide it into place. So here are the workers now installing these UHMW slide rails in preparation to slide the new bridge into place. So now we're ready to go. Here's the new bridge section. We've got these highly engineered steel wear pads, our UHMW rails. We've squirted the Dawn dishwashing liquid. These are the temporary supports that are holding up the bridge. And this is where the story gets interesting. This is the scissor-tailed flycatcher. And as you can see, he's been aptly named because he's having a snack right here. He has been honored as the state bird of Oklahoma, and he is protected by federal law according to the Migratory Bird Treaty Act of 1918, which is enforced by the U.S. Fish and Wildlife Service. That makes it illegal to disturb a scissor-tailed flycatcher under any circumstances, particularly when nesting. How many people in here are hunters or fishermen? How much of a sense of humor do game wardens have when you violate the rules? Not much. This particular scissor-tailed flycatcher thought it would be a good idea to build a nest on the new bridge. And he sat there for 4 months. So the construction crews, the engineers, the guys in the hard hats were all looking at the scissor-tailed flycatcher while the U.S. Fish and Wildlife game warden said, go ahead, disturb the bird. Now, where are my friends from Technetics? Where's Ron? Because you got to wonder in Texas how long that bird would have lasted on that bridge, or if they would have found a way to maybe encourage him to leave. So he sits there for 4 months. Eventually, he flies away. Now, thank goodness, he nested before they tore down the old bridge. So this did not cause 4 months of road closure at $20,000 a day. So here they go. They've got the slide rails all set. This is one of these giant screw jacks. This is a piece of threaded rod. They rotate this, and it's going to drag the new bridge into place. So here's the entire highway bridge section and the UHMW rail, and there's the jack, pulling it into its new location. Here are the workers guiding it into place. You can see the UHMW rails in the section. And here's a close-up, and you can see under load these UHMW rails with the chamfered edges so nothing will catch. And here are pools of Dawn dishwashing liquid underneath the UHMW to lubricate the process. Now, it turns out that UHMW worked beautifully in this application. It took only 7 days of road closure to make this new highway bridge. And the scissor-tailed flycatcher had some terrific entertainment watching the construction crews for the 4-month delay. So in summary, this is the first time bridge sliding was ever done in the state of Oklahoma. UHMW was the perfect material for the application, had the right friction and wear properties, the right mechanical properties. It had good toughness. It reduced the closure time and the environmental impact. And it provides a great example of how engineering plastics and high-performance plastics can be introduced into the latest construction technology. So many thanks to IAPD for including this application in the contest, and I'll take any questions you have. Yes, sir.
Excuse me, did you drag one beam over, or the construction company drag one beam over at a time, or a whole series of them together?
They dragged them one at a time, so it was 3 sections, and they just slowly pulled them into place.
Oh, okay. And was it concrete on the UH pad itself, or was there something underneath, a shoe or something?
I believe the UHMW was directly on the concrete, but then the bridge section had some specially engineered steel pads. And the engineer involved, Gus, said, I can't tell you what the steel pads are. He said, those are our technology, and they're specially made to do this. He said, the UHMW is yours, so I'll let you talk about that.
Okay.
You know, my guess is they just pitched it. When I think about 1,000 PSI with a material of limited compressive strength, I think they were lucky to get away with it once. And when I start thinking about anything over 15% of the nominal compressive strength, they start to worry about creep characteristics. Even if they'd squashed it, as long as it didn't crack, if it came from 2.5 inches to 2 1/4 and they got the thing over, I think they would have gotten off light. And for $3.5 million, I'd say they just toss those and buy more from us. Yes, sir. Okay, well, thanks very much. Oh, one more question?
What happened to the bird?
The bird got along just fine. So he had his entertainment and his laughs. Thank you very much for your attention.